Welcome back, Logan, to another installment of Math on Your Couch before a nice long weekend. Today I want to just go over dividing rational expressions one last time with you guys. Sometimes there's some special situations that might not be as obvious how to deal with, so I kind of wanted to talk about them. And then also do one last example of just kind of like, all right, so we're going to see every type of factoring and canceling. Looking at our first problem, we have a fraction, x to the power of 2 plus 9x plus 20 over 4x to the power of 2 plus 16x divided by x squared minus 25. So the first thing we want to do is we want to think about what it means to divide. And if you remember, I said divide is going to be the keep, switch, flip technique. So we're going to keep the first fraction, which is x to the power of 2 plus 9x plus 20 over 4x to the power of 2 plus 16x. We're going to switch the division to multiplication. So that's the switch of keep, switch, flip. And we're going to flip this guy. Now, don't be a goofball and do this. Please do not flip it this way. This is kind of useless to me. There's not a whole lot that I can be doing with this. So don't flip it actually vertically upside down like that. What I want you to do is I want you to change it to a fraction. So some of you might incorporate that 1 in the denominator, and then now you're going to switch it. So now you're going to flip upside down so that we have 1 on the top, and then on the bottom you're going to have x to the power of 2 minus 25. X to the power of 2 minus the 25. And now you're going to do what multiplication says to do, and that's multiply the tops with tops, bottoms with bottoms. I know anything times 1 is just going to be itself, so I'm going to write x to the power of 2. Actually, let's leave us some space because we might need a little bit more space. So it's going to be x to the power of 2 plus 9x plus 20 over, and then we're going to have to multiply the bottoms out. 4x to the power of 2, 4x to the power of 2 plus 16x. Now, since it's a polynomial, I'm going to put it in parentheses, and the other one's a polynomial, so now I'm going to put that one in parentheses as well, x squared minus 25. Now would be a good time to probably start color coding some things. So I'm going to use that guy in green, and I'm going to start factoring. So when I factor this, I need to think of factors of 20, 2, 10, 21, 4, 5. And the only one that can add up, and the reason I say add because there's a plus sign, the only one that can add up to 9 is 4 and 5. So we're going to factor this thing to x plus 4 and x plus 5. So we have x plus 4, x plus 5 on the top over, and then I'm going to color code this guy right here. This one is weird. It does look like they can both be divided by 4, so what I'm going to focus on is figuring out what the GCF is. So I'm going to factor out a 4 and an x, so I'm going to take 4x, and then when I factor out the 4 and the x, what's left is going to be an x right here, so that when I multiply it, I get 4x to the power of 2, and there will be a 4 there, so that I can get a 16x. So that's going to be that factorization right there. And then I have one more that I need to factor. We're going to factor out the x squared minus 25. These are the ones I like factoring. They're called differences of squares. That means x plus 5 and x minus 5. For those of you that forgot why you have to have one positive and one negative, it's so that you can cancel out the middle. You notice that there's no middle number. There's only a front and a back. So that means that that's going to cancel it out. All right, so now I take a look at it, and I see if I can cancel any factors. It looks like the x plus 4s are the same, and it looks like the x plus 5s are the same. And this can often lead to some problems because the entire numerator canceled. That means that there's a 1 up there. So we're going to put a 1 over, and then we're going to simplify. There's nothing left to cancel, so it's just going to be 4x times x minus 5. Now, technically, to simplify it, you must get rid of parentheses, which means we are going to have to distribute this thing out, and this is going to be 4x to the power of 2 minus 20x, all in the denominator, and the 1 still on top. And this right here is our answer for question number 1. That is how we simplify it. Just remember, when you're dividing by a polynomial, not a fraction, you might want to turn it into a fraction so that you can flip it. And you can turn anything into a fraction by putting a 1 in its denominator. All right, let's take a look at problem number 2. So with 2, what we have here is another division problem. So we're going to do the whole keep, switch, and flip technique on it. This is going to give us 8x to the power of 2. So we have 8x to the power of 2 plus 24x times, actually, I should not skip steps. Let's show everything. So we're going to keep it 6x to the power of 3 times, so we're going to switch the division, and then we're going to flip the second fraction to 3x to the power of 2 plus 15x divided by x to the power of 2 minus x minus 1. Now you can multiply, so you're going to multiply straight across. I am going to be a little lazy here, and I'm just going to do that. Oh, yeah, there you go. That's the ticket. All right, so then you're just going to put parentheses around these things right here, and technically you have now multiplied it. So it's now multiplied together. So now you want to go through the process of simplifying. That means factoring. So on the first one, I have a binomial, but it looks like there's a GCF right there. So I'm going to go ahead and start color coding this. This we're going to do in orange. So that's going to give me 8. They both can be divided by 8, and there's an x that they have in common at the very end. I like to use the last one when there's a GCF. That means they all have that x in common. As long as you have it in order, works out really well. So we have 8x times the quantity of x plus 3. And then I'll factor out. I'll keep going straight through it. So now I'm going to factor out this guy over here. This one also factors out a GCF, it looks like. Looks like there's a 3x in common. So I'm going to say times 3x, and then that would leave us with x plus a 5 right there. Over, so over, and then we need to factor the bottom here. Now, monomials I never factor. I probably shouldn't even put parentheses around that. So I'm just going to put 6x to the power of 3 times. And then now I want to factor this thing. It looks like you can factor, oh, I may have made a mistake there. It should not have been a 1. That probably, the original problem. You know what? I'm going to fix the original problem. The original problem right here, what I wanted it to say, I think was 12. So I wanted it to say 12, so there's a 12 right here. So now I need to think of the factors of 12 that we can subtract to give us 1. So the factors of 12 are 6 and 2, but when you subtract it, you don't get 1. Another factor of 12 would be 4 and 3, and when you subtract 4 and 3, you do get 1. So this is going to give us x minus 4 and x plus 3. Once again, sorry, you got a little flustered there. I probably should have color-coded this one right here. Right here. So these two guys are from this one here. All right, and then now we get into the canceling stage of this problem. And canceling monomials can be a little confusing, so I'm going to go with the binomials first, noticing that the x plus 3's can cancel. And then over here, I have 1x and 2x's. So I have 2x's that can cancel with this one. So these 2x's are going to cancel. Now it's going to cancel with 2 of the x's here, which means there's not going to be 3, there's just going to be 1 left because 2 of them cancel with those 2 guys right there. The next thing I notice is that 6 can cancel with the 3, so 6 and 3 cancel, leaving us a 2 down here. But then that 2 can cancel with the 8, so I'm going to cancel this 2 with this 8 right here. That'll give me 4, and that'll give me 1 right there, so nothing. So now I just have to figure out what's left. I have a 4 left, so I'm going to go through the problem that's highlighted in white. I have a 4 left, and I have an x plus 5 left. And then on the bottom, I have just the x minus 4. So I'm going to rewrite it as 4 parentheses x plus 5 in my numerator over x minus 4 in our denominator. And this gives us 4x plus 20 after we distribute over x minus 4. Now be real careful. Since you can't cancel anything over here, you cannot cancel anything over here. This right here is our final simplification. All right, if you have any questions, go ahead and hit me up on email or Google Classroom. You can even do that over the weekend. And if you don't, I'll see you guys next week. We do have a long weekend, so I hope you guys enjoy it. Nice, restful one for those of you who have been keeping up with your work, and a very stressful one for those of you that haven't, trying to finish up the last set of assignments. We are moving into the home stretch. We're almost done with the semester. All right, until then, I'll talk to you guys later.